Chloride ion maintenance and calibration. Function. The chloride ion sensor uses two electrodes to measure the electrical potential between a known ion concentration and the sample. The electrode on the sensor is a pellet of silver chloride in contact with the sample water. As the chloride ions dissolve from the pellet into the water, the excess silver ions build up an electrical potential that is measured with the reference electrode used by the pH sensor. The chloride sensor can be used in fresh or brackish water. However, the chloride ion levels in seawater will exceed the detection range of the sensor. Maintenance. The only maintenance required for the ion sensors is to keep them clean. Over time, the silver chloride pellet will deplete itself, and the tip must be replaced. Calibration. The ion activity in a solution is affected by the pH and conductivity of the solution. Prior to calibrating any of the ion sensors, the pH, ORP, and conductivity must be calibrated. If installing a replacement tip, the specific ion tip should be hydrated 24 hours prior to calibration. Determine whether you will be performing 2, 3, or 4-point calibration. A 2-point calibration requires a high and low standard, both at room temperature. For the high standard, use a 1.412 millisiemens per centimeter conductivity solution. A 3-point calibration requires an additional high standard at a temperature close to the expected sample temperature. A 4-point calibration requires an additional high and low standard close to the expected sample temperature and within 0.5 degrees centigrade of each other. Establish a connection to the sonde with Hydrolab 3LT. Click the button labeled Operate Sonde. When the sonde finishes its initialization, check the Parameter Setup tab. Then click the Chloride Milligrams per Liter tab. Type the number of calibration points you are using in the box and click Save Settings. If you change the number of calibration points, you will need to close the Hydrolab window and reconnect to the sonde for the change to appear on the calibration screen. Click on the Calibration tab, then click the Chloride Milligrams per Liter tab. You will see a picture of the probe as well as the current value, the date and time, the current temperature, and the voltage. Rinse and dry the sensors and attach the storage calibration cup. Fill the cup about 25% with the room temperature high standard and screw the storage cap on. Shake for 6 seconds. Remove the storage cap and pour the standard out. Fill the cup with room temperature high standard again, this time covering the ion tip and the pH sensor. Wait 5 minutes for the readings to stabilize. When the readings are stable, type a value of 1 in the first box to designate the high standard. Type 319 into the second box and click Calibrate. A calibration successful message will appear. Record the temperature and voltage reading. Rinse the cup and sensors with deionized water and dry them. Fill the cup about 25% with the room temperature low standard and screw the storage cap on. Shake for 6 seconds. Remove the storage cap and pour the standard out. Fill the cup with room temperature low standard again, this time covering the ion tip and the pH sensor. Wait 5 minutes for the readings to stabilize. When the readings are stable, type a value of 2 in the first box to designate the low standard. Type 46.2 into the second box and click Calibrate. A calibration successful message will appear. Record the temperature and the voltage reading. The two temperatures must be within 0.5 degrees centigrade of each other for a valid calibration. The low voltage and high voltage will have a difference between 40 and 55 millivolts on a tip that is functioning properly. This gap will shrink as the sensor tip ages and becomes less sensitive. If it falls outside the 40 to 55 millivolt range, it is time to replace the tip. If you are performing a three-point calibration, the third point, high-low, is with the high standard at a temperature close to the expected water temperature. If you are performing a four-point calibration, the fourth point, low-low, is with the low standard at a temperature close to the expected water temperature. The temperature readings for points 3 and 4 must also be within 0.5 degrees centigrade of each other, and the voltage readings should have a difference between 40 and 55 millivolts. The chloride sensor is now calibrated.